All right, everybody, today we're going to be looking at functions. So I'm going to start off with vocabulary. Make sure you have your math journals out and that you're taking notes. So the first thing we're going to talk about is what a function is. A function is some sort of relation or relationship in which each element of the domain, or your x values, is paired with exactly one element of the range, or your y values. So when you hear domain, that's your x values, and when you hear range, those are your y values. So in other words, this is another way of saying x cannot repeat. So in this set here of ordered pairs, I'm looking at my x values. They do not repeat. So this would be an example of a function. Now I've got mapping. Mapping is a way to illustrate how each element of your domain, or those x values, is paired with an element of your range, or your y values. All right. So here is my example. This is what mapping looks like. So when you see this, this is mapping. I have my x values here and my y values here. They're in order from smallest value to largest. That is normally how you're going to see them. Then this arrow here, this is my input and there's my output. So when x is -1, y is 4. When x is 0, y is 6. When x is 5, y is -2. So when you're looking at the mapping, what you're making sure is that you only have one arrow coming out of your x values. This side doesn't matter. We're only looking to make sure that there's no repeating x value. So this right here is an example of mapping, and this is a function. All right. Next, I have the vertical line test. If any vertical line passes through the graph of a relation no more than once, then it is a function. So here's my two examples. Here, and what we do is called a pencil test. So you'll take your pencil and you'll go across the line like this. And if my pencil only hits it once, which it does here, then it's a function. But as soon as it hits it twice, so like right here, I'm hitting this graph here and here. So I'm hitting it more than once. So as soon as I see that, I'm going to identify this line right here hits here and here. That's not a function. All right, so a function is a special relationship between values. Each input x has one output y. I have two examples here. These are sets of our ordered pairs. Here, looking 0, 5, 7, 11, x doesn't repeat. This is a function. Here's my next set of ordered pairs, -4, -1, -1, 5. As soon as I see x repeat, so that tells me not a function. So now we're going to look at some examples. All right, so first one here. All I'm looking at is my x values. The y values do not have any determination on whether it's a function. 5, 3, 2, 0, -1. This is a function because x doesn't repeat. If you find where your x's repeat, I want you to identify them, circling them like how I did on that example. -2, 0, 2, 3, 2. My 2's repeat. That is not a function. -4, -3, -2, 1, -3. -3 repeats. Not a function. All right, number 4, I want you to do for me. Look at your x values. Do they repeat? Is that a function? Correct, they don't repeat, so this is a function. Great job. Okay, now we're going to look at these as tables. Again, we're only concerned about the x's. Go down the x column. If you have a repeating x, not a function. 3, -1, 0, 2, 3, not a function. -4, -2, 1, 2, 5, yes. The x's don't repeat, that is a function. -5, -3, 0, 1, 2. Yes, it's a function. Those don't repeat. All right, I want you to try this one. Look at your x values. Is number 8 a function? All right, so you should have told me if this is a function. And what you should have found is that my 4's repeat, not a function. Okay, number 8, I want you to tell me if this is a function, or number 9, I'm sorry, number 9, is number 9 a function? All right, -8, -4, 0, 4, 8. It is a function because x doesn't repeat. And then the last one in tables, 1, 2, 3, 4, 5. Pretty easy to tell that one does not repeat. Yes, it is a function. All right, here we have our mapping. We have our inputs and our outputs. So we're only concerned about our x values. Remember I told you, I'm looking for only one arrow coming out of these numbers. So -3, -1, 2, 4. There's no repeating arrows. This is a function. All right, number 12, -4, -1 has 2 arrows coming out of there. This right here tells me that -1's repeating. That is not a function. 13, I want you to tell me if this is a function. All right, you should see one arrow coming out of each number. That is a function. All right, next we're going to look at the vertical line test. So the vertical line test can be used to determine whether a relation is a function, and we call that the pencil test. Again, we're looking for one point only to touch that pencil at a time. If when I'm crossing my pencil across that graph and I'm holding my line, I'm holding my pencil vertically, right? Vertical line test. Hold it vertically. Only touches once. So the function passes the vertical line test because it's a function. All right, here, and I've already identified this, so I would have gone through, and as soon as my pencil is crossing or intersecting that graph in 2 places, not a function. It has failed the vertical line test. So that vertical line test is what you're going to use whenever you have a graph. So let's look at some examples. All right, so here I have a graph, and it's just a bunch of ordered pairs. I'm still going to take my pencil across left to right, and the very first set of ordered pairs that I come across, my pencil is touching those at the same time. This is not a function. All right, so number 15. Take that pencil. It's only touching that point. Oh, it's only touching that point. Only the 1 point, 1 point, 1 point. This is a function because my x values never repeat. Okay, 16. Vertical line test. We take our pencil. All right, it only ever crossed that line once as I moved it. So yes, this is a function. All right. Boom. As soon as I touch it right there, this is not a function. It cannot intersect more than once. And it does. All right. I want you to look at number 18. Is 18 a function? Correct. As soon as I intersect, right, we're going to intersect. No, this is not a function. All right. Now, is 19 a function? Remember, vertical line test. All right, you should have taken your pencil across. I only intersect at 1 point as I drag my pencil across there. So yes, this is a function. And then, I mean, some people I know like to just draw their little, just draw a bunch of lines. It only intersects that once. That's kind of like the visual representation of what your pencil's doing. It's going across there, and it's only hidden here, and here, and here. Once I see vertically where it's intersecting twice, not a function. All right, so I've got 2 more examples here for you. All right. So this is the graph line right here. Here's the line here. Is 20 a function? All right, you should take your pencil across. Boop. All right, this repeats indefinitely. This is a line that has an undefined slope because it is not a function. Okay. Next, only is touching once so far, still touching only once. As I moved, I was only touching that line in one place. This is a function. All right. If you have any questions, please contact me at the end of my meet. Otherwise, have a great day.